All right, guys, happy Monday. Not here today, so what you are going to do is watch this video. Hopefully it appears for you. There we are. All right, so 10-2 is what we are going to do today. So real quick recap of what we did on Friday. You had two binomials that you multiplied. So maybe you had something like 2x plus 3 multiplied along the side of x minus 3. So then we use our box. In any order, you could write 2x plus 3 gets multiplied with x minus 3. All right, and we did multiplication like that. But today, we're going to do something a little easier because we don't have a binomial, but instead we're going to have one monomial. So remember, that is only one term times a polynomial. So it could be something like x to the fourth plus 6x squared minus 8. All right, so a lot of what we're going to be doing today is just distributing. We might have to combine like terms or solve equations, but that's going to be the main idea. All right, so first, let's go through our warm-up for today. So this could be found on packet page 6. So we have some addition problems and a subtraction problem. So when we talked about addition on Wednesday, you see that we have 5x squared minus 3x plus 4 plus 2x squared minus 4x plus 3. Okay, one way we could do this is just stack our like terms on top of each other. All right, so this first polynomial is 5x squared minus 3x and plus 4. All right, the second one here in red, we could stack right on top. So it would be 2x squared minus 4x plus 3. Now, it doesn't always work like this in which everything is written in standard form. All right, so both of these are in standard form because we have the x squared first term and then the x term and then the constant at the end. All right, so now remember, we're adding. So we have 5 plus 2, and we keep the x squared. All right, then we have negative 3 plus negative 4, which is negative 7x. And then we have 4 plus 3, which of course is 7. All right, now keep in mind, you could have done it a little differently. Instead of not writing that green polynomial on top of the red one, we could have just looked for like terms. All right, 5x and 2x. 5x squared, and 2x squared. All right, and then we could have also grouped those together, and then also found we got negative 3x and negative 4x. All right, this all gets added to negative 3x plus negative 4x. Now, some of you are confused when I say plus and negative. I just want to emphasize that we're still adding. Now, if you understand that plus and negative is the same thing as just subtraction, you could think of it as negative 3x minus 4x. All right. I'm sorry that this is getting all jumbled here, but the last thing you would do if you want to do like the horizontal method is to group 3 and 4 together. 3 and 4 go together. So regardless, you will still get 7x squared minus 7x plus a positive 7. Okay? Very good. All right. So as for subtraction, remember that one we did on on Thursday. It's a little different because what we want to do is we still want to add. All right. We still want to change this to an addition sign and then change each term. All right. Each term becomes the opposite. So this first, each term of the second polynomial. The first one stays, x squared minus 4x plus 3. All right, since we changed this to addition, all right, then everything in parentheses needs to become the opposite sign. So that would become negative 3x squared, it would become a positive 3x, and then it would become a positive 5, because that's a negative 5 becomes a positive 5. Negative 3x becomes a positive 3x. And then lastly, that 3x squared needs to become a negative 3x squared. So now what I'm going to do is I'm just going to, stack those on top, all right? So I'm going to come up right above the word simplify and just rewrite this as, all right, remember that first polynomial stays exactly the same, x squared minus 4x plus 3. And then below it, I'm going to write what I wrote out in green. All right, negative 3x squared plus 3x plus 5, lining up all my like terms. Now, some of you were confused. Maybe, for example, this one didn't have a 3x, so maybe it was negative 3x squared plus 5. Well, then you would have nothing here. So you could leave it blank and bring it down. Some of you were confused when I said you would need to substitute in a 0x. All right. You just leave it blank. But that's not what we have here because this is a positive 3x is actually present here. Okay. Sorry, here. Okay. So down here, we bring that here. All right. Now we have our like terms. All right. This is a 1x squared. And to remind you, we are adding. So we have 1 plus negative 3x squared. That would be negative 2x squared. Negative 4 plus 3 is negative x. And then 3 plus 5 is a positive 8. So that would be your final answer here. All right. The final answer from number 1 was 7x squared minus 7x plus 7. All right. And I showed you both methods. For number 1, number 2, again, you could have done it differently in grouping these together, all right, instead of stacking, okay? All right, which of the following statements correctly describes the polynomial? Number 3, all right? So first we could look at the terms, all right? How many terms we got? Well, I only see a minus sign, so I got one term on the left, another term on the right there, left and right, okay? So that tells me it has 2 terms, so we would call that a 2-term, 2 wheels on a bicycle, 2 terms in a binomial, all right? Bi means 2. Now let's look at the degree. Let's find the degree of each individual term. So this one in blue here has x to the power of 1 and y to the power of 4. And 1 plus 4, we would say that has degree of 5. The second one has a degree 2, 2 plus 2 gives us 4. So altogether, that would be the degree of 5 because it's the highest degree term. All right. Now for number 4, back to power rules. All right. First thing, let's raise each power or each product to a power. So it looks like we would start with 5. That 5 needs to be raised to the third. That x to the 6th needs to be raised to the third. That y to the 10th needs to be raised to the third. And last but not least, that 2 needs to be raised to nothing. So we could just write a big multiplication sign, raised to the power of 1, technically, x raised to the negative 8th, and then y squared. All right. Let's raise our powers. All right. Now, this is not a power to a power. This is a coefficient. So this is 5 to the third, which is 125. Now, this is a power to a power. So we don't do 6 to the third. Since these are both powers, we multiply them and we keep the base, x to the 18th. Same thing with y to the 10 to the third. So that would be y to the 30th times 2x negative 8 y squared. All right, next thing we need to do is we got a negative exponent. So we need to move it. X to the negative 8. That's what needs to move to the denominator. All right. So in the denominator becomes x to the power of 8 is in the denominator. Everything is still in the numerator. All right. So 5 to the power of 3 is 125. we got x to the 18th. Now, we do have y to the 30th. Then we have a multiplier of 2. And then we also have y squared. All right? Very good. So let's clear this up. Let's multiply our two coefficients, 2 and 125. That is 250. All right? There are more x's on top by 10 because we would do 18 minus 8 for x to the power of 10. And then there's more, all the y's are on top. There's 30 and 2. 2 powers, same base, add those exponents. Add those powers to get y to the power of 32. All divided by x to the 8th. Oh, wait a minute. Nope, we got rid of that. We got rid of it because the 8x is canceled out. All right, so that is our final answer for our warm-up. All right, very good. So let's get into today's lesson. We're going to start in your books, and then we'll go back to your packet. All right, so looking at this, we multiply a polynomial by a monomial. All right, the main thing is, all this is distributive property. All right, so that's all we're really going to be talking about today. We might talk about reviewing some power rules. All right, so if you're multiplying, you multiply your coefficients, but then you add your exponents as long as the base is the same. So we start with negative 2x and times by this polynomial 4x squared plus 3x minus 5. So we distribute, and you can see we distribute to each term. So we have negative 2x times 4x squared. Negative 2 times 4 is negative 8. X to the power of 3, because here we had x to the power of 1 and x to the power of 2, so we added those. 2 and 1 give us 3. All right, same thing with negative 2x and positive 3x. Multiply negative 2 and positive 3 to give us negative 6, and 1 and 1 give us 2. And same thing even with negative 2x to 5. All right, you get negative 10x. All right, and the only thing that we need to simplify really here is if we see a double negative, a negative and a negative give us a positive. So our final answer here will be negative 8x to the third minus 6x squared. Negative times a negative is a positive, so we would get a positive 10x. All right, so that's all for that first example. All right, let's take a look at example 2, where we have some more distribution. Remember, the key for distribution is you have to do it when you see parentheses. We see parentheses. What's on the outside of the parentheses needs to distribute in by multiplying. All right, so let's take a look at example 2. We start with 3n times 6n to the third minus 4n minus 2, 9n to the fourth minus 11. All right, and you can see your book does the same thing as me. Even you're subtracting a negative 2, they always wrote plus negative 2. All right, so we distribute, and then we have our product. So 3n times 6n to the third. Again, that's 3 times 6 is 18. Add your powers. N to the first, n to the third, give us n to the fourth. All right, 3 times 4. Negative 3 times 4 is negative 12. 1 and 1 give us n squared. Then same thing all the way down. Negative 2 times negative 11 is positive 22. Now you have to combine like terms. Notice it says to simplify. What does the word simplify mean? Well, if you had me semester 1, whenever you simplified, mean two things. First, you got to look to see if you could distribute. Then you see if you could combine like terms. All right, so it looks like they distributed for us already. Let's see if we have any like terms to combine at the end. So in that last line here, they looked like we had 18n to the fourth, negative 12n squared minus 18n to the fourth plus 22. All right, so Remember, like terms are same variable with the same power. So 18n to the fourth also has a like term of minus 18n to the fourth. So we group those here. All right. And then that negative 12n squared does not have another like term, so we just list that out. And the same thing with 22. But when we can combine 18n to the fourth minus 18n to the fourth, that just cancels out. And so all we're left with is negative 12n squared plus 22. All right. Very good. All right. So not a lot to write here just yet, but we'll get to those extra examples where you will have to do all of the writing. All right. So now let's take a look on page 556. We have a architecture problem. All right. So the world's largest basket is a building. Each face of the building is the shape of a trapezoid. Okay. All we need to know is that the largest face has a height of h and two bases with the length of h plus 90 and 2h plus 84. Write and simplify an expression to represent the area of one side of the building. So we're just looking at the area of that trapezoid. All right. So there's this formula for us. H is the height. All right. But then we have A is equal to and B is equal to. Those are their bases, A and B. So A, we could let be h plus 90, while B is 2h plus 84. All right, so the area of a trapezoid, we substitute those values in. So we have h plus 90 plus 2h plus 84. All right, so now what we need to do is, well, we have to look at what's inside those brackets, inside those parentheses specifically. We have a plus b, so we have some like terms there. So we have h and 2h. That gives us 3h. All right. Then we have this 90 and this 84. Use your calculator. 90 and 84 give us 174. All right. So now we have a monomial out here, 1/2 h, going to be multiplying into 3h plus 174. So let's show this distribution. So we have 1/2 h multiplied by 3h, all right, plus 1/2 h times 174, all right. So let's just write this out. This would be 1 over 2 times 3h over 1 plus, so 1 over 2 again, and we just know that the h is just out in front, multiplied by, we could say 174 over 1, all right? So now we have 1/2, 1 times 3h, that's 3h, over 2, plus, well, 1 times h here, we got 1 times h is 1h, times 74, we could say that's 174h, over 2 times 1, which is 2, all right? So we can't exactly simplify 3h over 2, all right? And real quick, I made a mistake. I forgot that this was 1/2 h, all right? 1/2 h times 3h. So we need to add in, this is 1/2 h. So 1/2 h times 3h would actually be 3h squared, okay? All right, this is to the power of 1. Sorry, just change that up. So that's how we get 174h over 2 there. All right, so my final answer here, 3h squared over 2, that cannot be simplified. But 174 divided by 2, that could be simplified. That would simplify to 87, and we would need to keep the h. So my final answer for that, example 3, is going to be right there. All right, now we also will have to do some equation solving involving this. All right, so let's take a look at some equation solving. So we have negative 16p is equal to negative 2p plus 3 plus 3 times 6p minus 30, all right? So we could see we got to distribute, all right? So when we distribute, we'd get negative 2p minus 6 here, and then 3 times 6p is 18p, all right? The next thing we need to do is, well, let's combine any like terms. We have negative 2p plus 18p would give us 16p, all right? And then a negative 6 and a negative 90. Negative 6 minus 90 is minus 96, all right? The next thing we would do is, well, we need to subtract 16p from both sides, all right? And then in total, we have negative 32p's, all right? These cancel. And then the last thing we need to do is divide by negative 32, all right? And p is equal to 3, all right? Very good. All right, for the sake of time and to get some more practice, we are not going to do b here, so let's move on to the check. All right, let's do the top check and not the bottom. So it looks like you have an equation. You have 2p is equal to, let's go ahead and distribute here. What's 3 times 4p? That would be 12p. And 3 times negative 10 is negative 30. All right, all your variables are not together, but all your constants are on the right. So let's move all of our variables to the left-hand side. All right, 2p minus 12p is negative 10p is equal to, those cancel, and we're left with negative 30. Let's go ahead and divide by negative 10 on both sides. All right, and we're going to get p is equal to 3. All right, very good. All right, now we're going to go back to your packet. And how it is on your packet is how you should expect it to be on your tests. Because on your tests, you're not going to have these blanks just to fill in. You'll have to do this right from the start. All right, so let's take a look at an example in your packet. So this is just like extra example 1. So if you had trouble, if you're having trouble doing this, you could try it before and then come back and check. All right, look at example 1 from your book. All right, so we got to distribute negative 3x times 5x to the 5th. All right. Then we add that to negative 3x. That also gets distributed into negative 3x squared. And then finally, negative 3x distributes into the positive 7. All right. So if we take a look here, we have 3x to the 1st times 5x to the 5th. So that's 3 times 5, which is 15. You got to add your exponents. And I'm sorry, this should be a negative 3x. So that's negative 3 times 5 is a negative 15, x to the power of 6, plus negative 3 times negative 3 is positive 9, x to the power of, well, this is 1 and 2. That gives us to the power of 3. All right. Multiplying exponents with the same base, add the exponents, keep the base the same. Multiplying the coefficients, though, negative 3 times negative 3 is negative 9. And lastly, we have negative 3x times 7. That would give us a minus 21x. So our correct answer for this one would be A. All right, let's take a look at extra example 2. All right, we got a lot going on here, okay? So we have to distribute twice, it looks like. All right, first we distribute 2n into 5n to the 3rd. All right, that's 2 times 5, that's 10, n to the 6. Or wait a minute, 2 times 3, nope, going too fast. 2 and 3, that's to the power of 5, plus 12n squared. All right, going over here, we have a minus. All right, so I'm going to write a negative 5n gets multiplied by a 3. Negative 5 times 3 is negative 15. We have n to the power of 1 times n to the power of 4. That gives us n to the power of 5. Negative 5 times a positive 3 again. That's another negative 15. N to the first and n to the second give us n to the 3rd. All right. Now I look, do I have any like terms? Let's see here. I got n to the 5th here and n to the 5th here. got to be in standard form. That's my highest degree. So I have 10n to the fifth minus 15n to the fifth. That's negative 5n to the fifth in total. All right. But then all of these, so I took care of those two, but these two are not like terms. All right. Minus 15n to the third is not a like term, and neither is plus 12n squared. All right. So if I look here, it looks like my correct answer will be B. All right. Very good. All right. This last one, real quick, you have volume is equal to length times width times height. But it tells us that we could only use width. So we need to define length as a version of width. Well, it tells us right in here in this problem the same width and length. So L is actually equal to W. So instead of L, we could just put in another W. As for the height, that tells us it is 2 feet shorter than the width, 2 feet shorter. So we do W minus 2. All right. So substituting all of those in, we have V is equal to, well, length. Instead of length, we're going to put W. All right. And then instead of the H in height, we're going to put W minus 2. And then, well, I guess I did L times H first. Well, let's do length times, we already did length, that's W. And then we said width is also W, so that's W times W. All right. And then the last height is going to be W minus 2. All right. You guys understand that we have W squared here. W times W is W squared, W minus 2. All right. So that tells me my correct answer for that one would go ahead and be B. Now, if I go ahead and distribute this, I could simplify it more. W squared times W minus W squared times negative 2. All right. And sorry, I would need to add because I have a positive W squared times a negative 2. All right. W to the power of 2 and 1 is 3 plus W squared, and then this would be a negative 2W squared, so it would have to be minus 2W. All right, so filling this in your notes on packet page 8, this would be W to the power of 3 minus 2W to the power of 2. All right, so for tonight, you need to do homework number 4. Okay, this is homework 4. And I wanted to let you know that homework 3 and 4 will be checked on Tuesday. All right, feel free to reach out to me if you have any questions, and we will see you on Tuesday.